As we already know, most applications today call for a security schema so that only allowed users may have access. This is in addition to the authorization or restrictions for access to the various parts of an app, according to the permits assigned to each user. This implies ensuring that all users who access are duly authenticated, which is to say, the user must be who they say they are. And they have to be authorized, which means once the user is authenticated, they must be allowed access to only specific parts of the application. In the case of web apps, because they have several access points, any object accessible through URL must verify authentication permits. This means that each object must include the security check to perform the corresponding verification. In the case of apps for smart devices, because these applications are distributed, part of them is executed on the device itself, and the business layer of the app is solved through REST services with an access URL, so they're not exposed to unwanted accesses. Just like in the case of web apps, what we must do is verify that only duly authenticated and authorized users access the application, thus avoiding the execution of users who are non-compliant with that condition. To fulfill all these needs, GeneXus provides us with a security module known as GeneXus Access Manager, or GAM, which solves authentication and authorization functionalities for both web and smart device apps. The GAM was developed by GeneXus, so it's easily integrated with the app's KB. It enables a centralized solution for everything relative to security. The purpose is for the security solution to be used as declaratively as possible within the application without creating additional complexities. The GAM also provides a backend that enables the definition of users, permits, security policies, and access to objects, among other things. Additionally, it offers an API to access many of these functionalities in a programmatic manner. What's used to internally solve the authentication is web sessions for web application security and OAuth to solve security in the case of SD apps. For authorizations, the implementation is based on roles using the model role-based access control, with which methods, properties, and everything necessary to handle the app's authorization are encapsulated. The GAM provides different authentication types. Local authentication using GAM, where users and all their credentials are stored in a proprietary database or also in a remote manner, because an application that uses GAM may become an identity provider. In this case, other apps with GAM may be remotely connected to this server to obtain authentication from there. We can also use other external identity providers. These provide authentication based on the protocol OAuth 2.0, like Facebook, Twitter, and Google, Instagram, Office 365, Mercado Libre, or LinkedIn. Here, standard authentication mechanisms are used, all based on the protocol implemented by these applications. In this case, there's no need to define local users. In other cases, it's often necessary to integrate our app with other applications with which we have to exchange information, and it becomes necessary to ensure that users are authenticated through an external authentication of the app. One way to perform external authentication is to use a SOAP web service, which is provided by the other app, and to set up the GAM for it to consume that web service. It's possible the other application might provide an external program to solve the authentication, but it's not exactly a web service. In such a case, we set up the GAM to accept authentication of the custom type. With the authorization, we define execution permits of objects and permits for operating modes and transactions. The definition is done by granting each object's permits for each role. The effective permits on the object will depend on the role assigned to the user. This validation is done on the following web objects: web panels, web components with property URL access equals yes, and transactions. Additionally, a verification is made on permits for the insert, update, delete, and display modes of web transactions, and for smart devices of the objects, work with for smart devices, and panels for smart devices, and the insert, update, and delete actions on the work with for smart devices. The GAM also shows an API, Application Program Interface, to access its properties and methods, in case we need to do it from our app and a series of web services that may be used from other apps. This topic will be dealt with at the advanced level. In order to enable the GAM, we must go to the KB's active version level and set up the property Enable Integrated Security to True. In the trial version, it's in the first node of KB Explorer under the name of the KB. Once we've enabled the GAM, we'll see another property called Integrated Security Level that allows us to indicate the default value of the security of objects in the KB. This property is also at the object level, so it's possible to customize the way in which security will be implemented in that object. There are 3 possible values. None indicates that the object will be public, which means it won't have security. Authentication indicates that only authenticated users will be able to execute it. Authorization indicates that users, in addition to being authenticated, must also be authorized to execute that object. That is to say, they must have the role appropriate for executing it. Once our security properties have been set up, the GAM objects will be automatically imported in the KB, and then we'll have to do a rebuild all with that. When we do that, a dialog box will open up telling us that the GAM module will be installed in our KB, with the solution ready for both web and smart devices. GAM is also prepared to execute on a database independent from the application's database if required. In such a case, we don't need to be concerned with this structure. This is because it has a schema of its own, associated with an independent data store in the KB. This makes the full configuration independent. Additionally, GAM will initialize and maintain the whole database fully updated. Now we'll go to GeneXus to use GAM. We'll go to the properties of the knowledge base and click on Event Day, the name of the KB. And we enable the GAM and set the value of the property Enable Integrated Security to True. This dialog indicates that the integration will take place. Here, we can indicate whether we want to integrate the web backend, and with this other one, we indicate whether we want to integrate security for smart device panels. With this combo, we can choose the way in which we want this module updated. It may be automatic, or we can choose to have it ask us, or otherwise that it never be updated. We press Yes. Additionally, the GAM objects are being imported in the background. Note that now we have the integrated security level property available. In this property, we can indicate whether we want to enable authentication only, the default value, or if we want authorization, or if we don't want any security at the KB level. Additionally, an application ID is assigned to be used in the GAM repository for identifying the app. Now, we already have the properties where we indicate the login objects. One for the case of authorization error, and another one to change the password. In the KB, we already see that some folders have been created in the root module. GAM examples are example objects we may modify. Here we'll have the backend and front-end objects for both web and smart devices, and GAM library with the API, all of which are external objects. We also have a new data store, GAM, with the data on that connection. By default, the same base as the data store default is assumed. But we have a schema of our own for the tables. So, with the import process concluded, we do a rebuild all on the application. GeneXus tells us that the GAM database was not found and asks if we want to create it. We say yes. Now the database is created with all the tables, and followed by the initialization of the database. Let's wait until the generation is done. Now we already have the application. And now we go to the emulator, where the first thing we find is the login screen. When we try to access without a user, we get an error message. All of this is provided by GAM automatically. In order to access, we'll use a user created by default, admin, with the password admin123. Now the application opens up. We won't save the credentials. And the app continues to function normally. And now we go to the web. Here we have the developer menu. If we try to access an object, such as, for example, home, we will be redirected to the login screen. We'll apply the same user, admin, and password admin123, and now we can access. And now we can access the objects. And the web continues to function normally as well. This is the end of the introduction. In our next video, we'll see further details about the GAM.